To cut threads here on the lathe, I like to use these inserts. And because it's carbide, it's nice and hard and they last a long time and they cut very well. The problem is when I cut threads deeper than, let's say, 1.5 or 1.75 millimeters, it doesn't work so well anymore. I don't know why it is, but when I cut deep threads, these things, instead of make a clean cut, they rip out the chip. And the result is that the cut thread, the finished product, looks like shit. And because sometimes I have to cut threads deeper than 2 or even 2.2 millimeters, I made my own thread cutting tools in high-speed steel. One at 60 degrees and the other one at 55. And these work very well. It's just that after some time, when you cut a lot of threads, because for example I had to make these spacer bars and really long threaded parts on it 5 times, which means these things wear quickly. I can cut one long and deep thread with it and then I have to regrind. That's not really handy. And then I had a little idea. Because I have this cutting tool, it's of course an insert triangular 60 degrees, just like the to cut thread. Maybe this one could work. And I tried it and it does work. The profile of my triangular tool here is a perfect match with all kinds of big threads. Now it's not perfect, but it's really close. So I tried it and it worked. But if you look at whatever thread you want to cut from close by, of course we can see that it is not 90 degrees. The threads, they represent themselves a little bit in an angle. But because my cutting tool is horizontal, which means not in an angle, the clearance angles on the cutting side and the free side, they are not perfect. And while cutting my big threads here on the lathe, I could hear something was wrong. It was very subtle and the cut thread, the results were not bad at all, but it wasn't perfect. But that will be of course easy to fix. All I have to do is to make a little tool holder like this one, but with the same angle I have here on my blackboard. And I figured out that it is 2.5 degrees, more or less. So I started cleaning up a piece of material too big. I can make 2 of these tool holders out of this piece. So easy peasy, all I had to do was cut it in 2. And to do so, I used the little slitting saw. And as you can see, I already started. Maybe you can just make out a little bit of cut here. But while cutting, this milling machine was making terrible noises. It happened before that my milling machine made terrible noises like this, and then especially while cutting, while the cut is interrupted, for example with using a 2-flute end mill or something, it's rattling. But this time it was terrible, and I immediately stopped doing what I was doing. And to investigate a little bit closer, I took the head of the machine, and here it is on my welding table, of course lying on its side. This part comes of course on top of the milling machine, and here is a spindle with the cutter, right? And after a little bit of investigation, there is not much to see. In the spindle itself, there is a tiny little play. I mean, not play in the spindle, but in the gear system in here. But gears, they always have some play. And way more complicated to show you on camera is this little gear here. There is play with the main axle inside here. So the shiny thing you see in the hole is this main shaft, and the gear is of course keyed on it. And when I turn the spindle by hand and I hold the gear with my thumb, I can feel a little bit of play. It's not much, but I think it's too much. So, project for today, and it was a really long intro, I know, but project for today, take this thing apart and see if we can do something about it. Just to make it a bit easier to manipulate, I take the head off with the main spindle here. It's very easy to take off, but put it back on, that's a nightmare. Because in this part, I hope you can see it a little bit, there are these sliding T-nuts. And they have to be in the right position, of course, to put the bolts in. But as you can see, they tend to escape. So put it back together. It works, but it's a challenge. And here's maybe a little bit a better view. Inside this shiny part is of course the main spindle that slides in and out, and it's driven by this gear that takes in this gear here. And here absolutely no play, and the gear in very good condition. And this gear is of course mounted on the main shaft that's inside here, and there is absolutely no play, and the gear is also in very good condition. That's good. Now it's maybe important to note that this thing here, I never had it apart, which means this is not a how-to video, but let's figure it out video. On the back here there are two Allen key thing bolts that I suppose hold this aluminium protection part in place. And here there are two screwdriver screws. And this one is bent. That's not good. It looks like the shaft has to come out first, because this part here goes all around, and the other one too. And here are two more Allen bolts that I don't know what they're holding together, but we'll find out. First, a little bit of clean. Okay. It could well be that I already fixed it. Now, as you can see here, on this side there is a cap, some kind of end cap. Which means that if I want to take this shaft out, it needs to go that way. That also means that if I really want to take this shaft out, first thing to remove is of course the gear, because here is part of the casting. So the gear has to go before I can take it out. And that also, of course, also means that this gear is held on by some kind of system. And after closer inspection, it appears that this gear is held on by a special nut, exactly the same as on this side. And this nut in between here was loose. And because I don't have the right tool to go in between here to tighten it, I used the punch and I put it in my nut here. It's a little bit fiddly, but it works, and I gave it 2 light taps with a hammer, and now the gear is tight, no play at all. So I think it's good to go again. Let's put it all together and give it a try. We are now a few days later, and while the other myself is putting my milling machine together, I would like to present you a brand new sticker that came this week from Modeling Mark. Mark and his workshop are located in the UK, and for the moment he's working on this universal tool grinder, what I think is a really interesting project. And while I'm trying to peel off this back paper from this sticker, doing fine, Rusty? All good? Okay, let's go for it. As you can see, Mark, your sticker is now on the sheep door. And of course, as always, link in description. Right, it's all back together again. And I installed the saw blade at the right height to continue the cut I started a couple of days ago. And let's see what happens. It is still making exactly the same rattling noises, and the sound comes from these 2 gears I showed you a little bit earlier in this same video, the 2 gears between here. But of course the saw itself is not completely engaged in the workpiece. Every time I use this thing, when I start cutting, it's rattling, but when the saw is completely inside the workpiece, is completely engaged, it works like a charm. So I will continue cutting even with the rattling, and I will bring you back when we're a little bit further here and see what happens. It worked! I think this is a typical example of how a simple little project, making a tool, becomes way more involved than we anticipated. All I wanted to do was make a simple tool to cut big threads. And then I see that the tool, to make the tool, doesn't work so well. So let's fix it. But fixing the tool was a little bit a fail. But still, we could make it work, so that's good. So finally, after all this, I have 2 blanks that I can use to make insert holders. And first I will make 1. The plan is of course to put my insert holder here in the tool post, and when I put it in without any shims or whatevers, it has to be on center. So here on top of course comes my little insert, I suppose you get a point. And this height gauge is installed exactly at center of the lathe. So I suppose first I'm gonna cut off all the material that I have too much here. I will leave it a little bit oversized because of course the little insert that falls off, this little insert has a thickness of 6 millimeters over to the shaper. And I said that I should make only 1 little insert holder, but because both have way too much material and after finish they will look both more or less the same, I will rough them out both at the same time. All set up and ready to go. Oil everywhere, and I have to take off more or less 6 millimeters, what I think I'm gonna do in 6 passes. Machine is set at 160 strokes a minute. And with a work length of 100 more or less, it will give a cutting speed of 25 meters a minute. Exactly what we need. That's good. Let's go for it. Shape it, baby! I stop a moment after the first pass that of course didn't clean up everything, and here the surface finish is really rough, and when the cutting tool comes over here it's really violent because these holes here, I think they were flame cut or laser cut or something, and the rim of the hole is really hard. So my cutting tool is not really happy with the treatment I give it, but you will have to learn to live with it. after regrinding the tool, it sounded a lot better. Now, the finish isn't great, but it's not important. There has a lot more to come off, of course. To install my little insert in my future tool holder, of course, I have to cut down the pocket at blackboard 23.3 millimeter. Of course, in an angle of 2.5 degrees. And the 23.3 is the center of the pocket. Because it's an angle, it will vary, but center. And I think that's a really nice little job for the decal. I installed my part with a nice stick out here. And the only reason is, of course, it's easier to take measurements. If it's in here, it's complicated. And I also took out the parallels. So if I'm gonna drill, I'm sure I will not drill in them. And to avoid stupid mistakes, I drew out a little line here in an angle. Which means that my part has to tilt that way, 2.5 degrees. Very handy to avoid mistakes. But of course it's not guaranteed that it works. Installed at 2.5 degrees, that way. Installed the 4-flute carbide cutter, 12 millimeter to be precise. And I touched off and set 0 at all my analog readouts. And let's start cutting. And now let's make a little jump into the future, because here is a finished product. Now I didn't video the operations here because otherwise it will take way too long and I'm sure we'll fall asleep watching this video. But nothing special, I just cut off the material here around this little insert and I reduced the shank, so now I can choose, although I can put it in my lantern tool post here, or I can use the quick change tool post, so now it fits in both. And as I said, when I put it in, no shims, no nothing, and it is on center height. And I suppose there's only one thing left to do now, and that is of course give this thing a try. I will cut the same thread as I have on my big bolt here, and I can test fit because of course I have the nut that goes on here, and after a little bit of check I figured out that the pitch of this thing is 4 millimeter. I think for the hobby shop it is a big thread. So let's go for it. Now this is for me a perfectly used piece of steel because there's a crack over the whole length here. So I can do nothing with this. Too dangerous. But to test my brand new little cutting tool here, I'm sure it will be good enough. And it's maybe a good idea to also install some cutting tools. And my brand new thread cutting tool. And I even marked on top here that it's a 2.5 degree tool. That's good. The diameter of this piece of rust is more or less 40 millimeters. And I need to reduce it to, I check on my blackboard, 35.3. Let's do this. This steel is rather hard, but it cuts very well. But it's throwing chips everywhere. So I think it's a good occasion to test my brand new chip flying against in-face shield thing here. Right. This is the piece of material I first installed here to try cutting my threads. And now it is two size and it's a very nice finish, but I took it out because I think this is too hard and it destroys cutting tools. And I don't believe it will work very well to cut 4mm threads. I also switched inserts. These dark ones I used, they work well, but they have a lot, and I mean really a lot of tool pressure. So now I installed, of course, also a triangular, but another type that cuts a little bit better. As you can see, I used another piece of material that I already cut to size, and I think I'm ready to cut threads. Let's give it a try. And this is the result after a bit over 1mm depth of cut. And I think it's not looking too bad, so let's continue. And here's the result. And I think I cut a little bit too deep because it's a tiny bit wobbly, but whatever. Now this thread, I just cut it, that's all. No cleanup, no, nothing. Just cut, put the nut on, that's it. And there were no weird cracking noises or whatever. And I think if on your hobby lathe one day you need to cut big threads, this could be a solution. So go for it.